We will discuss now Quorum's technique in the crash stop process model. So a quorum for a set of n processes in the crash stop process abstraction is a set of a majority of processes. So it is a set with at least the floor of n divided by 2 plus 1 processes. So let us see exactly what this means. If n is equal to 5, then the floor of 5 divided by 2 plus 1 is equal to the floor of 2.5 plus 1, and that is equal to 2 plus 1, which is equal to 3. So you do a division and you take the integer just equal or below this division. And if n equal to 6, then the floor of 6 divided by 2 plus 1 is equal to 3 plus 1, which is equal to 4. Some algorithms will rely on a majority of processes will not fail, and that is important. So a minority of processes will be faulty. So normally the maximum number of faulty processes that the algorithm can tolerate is less than half of the processes in the system. And this is exactly what we call the resilience of the algorithm. F is the resilience of the algorithm. So algorithms using quorums will work and satisfy both safety and liveness only if a quorum of correct processes can be established. If not, liveness will not be satisfied, but normally safety is always satisfied. So let us look to some properties of majority quorums. And remember again about majority quorums. Normally a process sends message to all processes and waits for a quorum. So let us see what are the properties of majority quorums. F is less than half of the number of processes in the system. So the first property say that two quorums always intersect in at least one process. So this is a picture, and we have 5 processes. So a quorum will be at least 3 processes. As you can see, these two quorums intersect in one process. And why is that? Because a majority is larger than half the number of processes. So a majority here will be 3. So any two such sets with at least 3 elements will have a non-empty intersection. Here is the next property of quorum. There is at least one quorum with only correct processes. If you look to the same example, so this quorum have only correct processes. Why is that? Since the set of all processes is equal to the set of correct processes union the set of faulty processes, and the number of correct processes is at least a majority, we have always a quorum of correct processes. And that is our assumption. We always assume there is a set of correct processes that will survive the system, and therefore that set of processes is a quorum. The next property is quite interesting, which is there is at least one correct process in each quorum. So let us look here. So we have this quorum has one correct process. This quorum has one correct process. And say, you see, this quorum has one correct process, at least one, and this quorum has at least one correct process. And this is because faulty processes are a minority, so any quorum will have at least one correct process. We will use this property in this lecture in the fail-silent algorithm. We rely that there is always one correct process, and we will use it to do some work. You will see that in this lecture. So again, quorums are used in the fail silent and the fail noisy algorithm. And as I said before, a process never waits for a message from a majority of processes, otherwise it can get stuck.